So the next problem we are discussing from the stylus SDE sheet is the problem number 3 from the day 4. So the longest consecutive sequence. So what the problem states, we are given an unsorted array of integer nums. We have to return the length of the longest consecutive element sequence, and we have to write the algorithm in order of n time. So we are given an unsorted array. What we have to return? We have to return the longest consecutive element sequence. So what's the longest consecutive element sequence here in this array is, we can see 1, 2, 3 and 4. So we can see a sequence of length 4. So from the given array we have to find the longest consecutive sequence. So what's the naive approach we can follow is that we can sort the array. Okay, sort the array, and after sorting the array, what we'll do, and for the given test case, let me do the thing. We can sort the array, and we'll count for the longest. We'll count for the longest element sequence, because if we have the sorted array, then it would be easy to find the longest consecutive element sequence. So if we sort the above array, what we'll get, sort the above array, what we'll get, let the sorted form of the above array is this. Okay, so we'll start from this. We'll check if the next element is equals to the element that is present in the current index plus 1. If that is the case, we're gonna increase our count. We'll currently, if the one element is itself in the sequence, so we'll start our count from 1. If we found that the next element is equals to the element that is present in the previous index plus 1, then we're gonna increase our count become 2. At this element we're gonna check if the next element is equals to the current element plus 1. So is that is the case, we're gonna increase our count. For this element we're gonna check the next element is equals to 1 greater than the element stored at the current index. We're gonna increase our count. For the next index we're gonna check if the element stored at the next index of the current is equals to the 1 greater than the element stored at the current index. If it is not the case, we're gonna store it in the variable. We can maintain a variable that is our answer or mx, answer variable, that will return the maximum longest, the length of the longest consecutive element sequence. So currently is 4. For the 10 we'll decrease our count to 1. For the next we'll check if the element stored at the current index, the element stored at the next index is equals to 1 plus the element stored at the current index. If not the case, then our count remains 1. So at the end we'll return our maximum answer. So this approach requires a time complexity of order of n log n to sort the array, and order of n time to search the longest consecutive element sequence. So this approach majorly take n log n time complexity and a space complexity of order of 1, because we are not using any auxiliary space. So can we optimize this approach? Definitely yes, because what we'll do, so how can we optimize this approach? Because it is already mentioned in the question, we have to solve the question in the time complexity of order of n. So what we'll do, we'll store the array elements in a unordered set. Okay, we'll store these elements in an unordered set. We'll store these elements in an unordered set, and then what we'll do, we'll check if the while iterating over the array, we'll check if the current element is the beginning of the sequence. If the current element is the beginning of the sequence, then we're gonna find the next element if there is the next element that is present in the array. So it would be more clear when I will do a dry run. So we have stored the all the array elements in the unordered set. Then what we'll do, we'll iterate over the array. So currently I am at this position. We'll check if this element is the starting of the sequence. So how will we check if the if the one less than this element, that is the current element, is present in the array or not? We'll check if 99 is present in the array or not. If 99 is present, then this is not the beginning of the sequence. Okay, and if 99 is not present, that means 100 is the beginning of the sequence. So what we are doing, we are checking if the sequence starts from the current element. For the present case, it is 100. We're gonna check if our sequence starts from 100, and if our sequence starts from 100, we're gonna find the next element to the 100, that is we're gonna find 101 if it's present in the array or not. Okay, so how will we find it? If 100, if the element that is one less than the current element is not present in the array or not. So we'll check if 99 is not present in the array. So yes, 99 is not present in the array, so it is the beginning of a sequence that starts from 100. We're gonna check for the next element 101 if it's present in the array. So 101 is not present in the array, so our sequence, the length of the sequence is 1. So our current longest sequence is of length 1. Okay, then we'll move to the next element, and for the next element we again gonna check if it is the beginning of the sequence. If 4 is the beginning of the sequence, then 3 will not be present in the array. So we're gonna check it in the hash map if 3 is present. Yes, 3 is present. So we don't gonna check for this one because it is not the starting of the sequence. Move to the next element. We're gonna check if this is the starting of the array. If this is the starting of the array, then 199 will not be present in the hash map or in the array. So we're gonna check if 199 is not present in the array. 199 is not present in the array. So this is the starting of a sequence that starts from 200. So what we'll do, so 200 is the starting of a sequence. We'll check for 201. Is 201 present in the array? No, 201 is not present in the array. So we'll return the length of the sequence as 1. So currently our longest sequence is of length 1. So our answer remains the same. Again we move to the next element. Again move to the next element, that is this. We're gonna check if 1 is the starting of a sequence or not. If 1 is the starting of a sequence, then 0 will not be present in the array. So we can check 0 is not present in the array. So 1 is the starting of the sequence. 1 is the starting of the sequence. So we're gonna check for 2. Is 2 present in the array? Yes, 2 is present in the array. Then we're gonna check for 3. Is 3 present in the array? Yes, 3 is also present in the array. Then we're gonna check for 4. If 4 is present in the array? Yes, 4 is also present in the array. We're gonna look for the if the array element is present in the array in the unordered set. Okay. So 4 is not 4 is present in the array. Then we want to check for 5. That 5 is not present in the array. That 5 is not present in the array. So the longest sequence is of length 4. Currently the longest sequence is of length 4. Then we will move to the next element. So the next element is 3. Is we gonna check if 3 is the starting of the sequence. How will we gonna check? How will we check if 3 is the starting of the sequence? If 2 is not present in the array but 2 is present in the array. So we're gonna drop it. We move to the next element. We're gonna check if 2 is the starting of the sequence. No, 2 is not the starting of the sequence because 1 is present in the array. So we're gonna drop it and move to the next element. So our array end here, and the longest consecutive sequence which we can return is of length 4. So we'll see the code for it. So we have maintained an unordered map, unordered set, and store all the array elements in our set. And we we have maintained the condition that the array element 1 is itself consecutive. So we will start with the length of 1, with the count length of 1, and the maximum length, it is the maximum length is 1, and our count is gonna and our count is 1, maximum length is 1. We're gonna iterate over the array and check if the current element is the starting of the sequence by checking if the current element -1 is not present in the array. If it's not present in the array, we wanna check for the elements, for the consecutive elements, consecutive increasing elements. If they are present in the array, we wanna increase our count. Otherwise, we wanna break the inner loop. And at every condition, we are at every iteration we are storing the maximum length. We are maintaining the maximum length. Okay, and we are returning it. Okay, so at the end we'll return the maximum length. Okay, we'll return the maximum length and we'll run the code. Our code runs successfully. Oh, one thing we have missed is the base case. What is the base case? If num size become equals to 0, we're gonna return 0. So we'll run our code and we're gonna submit it. It is accepted successfully. So this is the approach we'll follow to solve the problem.